Okay, so hi everyone. This is a question from KROTOV, and let's start with the solution of this question. Now, let's start by reading the question. A horizontal cylindrical vessel of length 12. So, we've been given that the length of the cylinder is 12, is separated by a thin heat insulating piston. That means that this barrier won't allow the heat to get interchanged between these two boxes, right? And this piston actually divides this setup into two equal parts, each of which contains n moles of an ideal monoatomic gas at temperature T. Now, the piston is connected to the end faces by the vessel by undeformed springs of rigidity K each. Now, when an amount of heat Q is supplied to the gas in the right part, the piston is displaced to the left by a distance L by 2. Determine the amount of heat Q dash given away at the temperature T to a thermostat with which the gas in the left part is in thermal contact all the time. So what we are being said is that in this setup, if we are putting heat Q in this side, yes, we are observing that Q dash heat is being released, and we are interested in finding this. Now, at equilibrium condition, what you need to understand is that this piston gets shifted by a distance L by 2, right? This is the question that is being said. Yeah, okay. So let's start with the solution of this question. Okay, now I start by writing a statement. Okay, that since total volume is constant, okay, so work done on this system is supposed to be zero, right? Write for the convenience. Okay. You need to understand that this is the net PV work done, right? The pressure work done on this system is zero. So now by first law, okay, so by wait a second, by first law, all right, we can say that Q minus Q dash will turn out to be the change in total energy, the change in internal energy plus the potential energy that is being stored in the springs. And what will be that? You need to understand that if this shifts by a distance L by 2, then the net summation of the potential energies in these two springs is going to be half into 2k into L by 2 whole square, right? Now let's focus on this term delta U. Delta is nothing but the change in internal energy of this part plus this part. Okay, we can add them in a scalar way. Now you need to understand by the language of this question that this side, the left side, the temperature is being constant. So the change in left side for internal energy is going to be zero. I will write it for the convenience. Okay. Now, since left side, hold on, side is isothermal, delta U 1 is going to be 0. I am considering the internal energy of this side to be delta 1. Now, we are interested in finding the change in internal energy of the right side. Let's assume that to be delta U2. Now, we can write delta U2 is going to be nothing but N 3 by 2 R into change in temperature after the expansion of this side. So we're interested in finding the change in temperature of the right hand side. And if we are with this result, we can simply put this delta U2 in place of delta U and we can find Q dash. Okay. So all these things will boil down to one simple thing. Okay, what is the change in temperature of the right hand side when this piston has been shifted towards left by a distance L by 2? Okay, so I'm trying to explain it with the diagram again. Okay, so give me some time to draw the diagram. Let's assume that this piston has shifted by a distance L by 2. Okay, and the temperature this side is T, and the temperature in this side is going to be T plus the extra temperature change, that is delta T, right? Now pressure on the left hand side is supposed to be P1 and the pressure on the right hand side is supposed to be P2. You need to understand that these two sides have the spring attached. Okay. Now for the equilibrium condition, you will have to understand that P2 is equals to P1 plus KL by S. S is nothing but the area of cross section of this side. Alright. And for the right part, okay, I can write NR T plus delta T, okay, the volume S into 3L by 2. This area cross section into length of this side 3L by 2 is equals to pressure in this side. And, and pressure in this side is supposed to be P2 and P2 is nothing but P1 plus KL by S. Okay. And what is P1? P1 is again nothing but nRT divided by S L by 2 plus K L by S. Okay. So from here, if you solve these two equations, this equation and this equation, delta T will come out as 2T plus 3K L square divided by 2NR. Okay. Now our main intention was to find delta T, and if you are there with the result of delta T, you can simply put it here and get delta 2, and when you substitute delta 2, Q dash will come out to be as Q minus 3nRT, this is T, alright, minus 5 by 2 KL square. So this is the solution to this question. I hope this is helpful, and just before starting the video, just give it a try. This is a very good question, and so eventually help you in developing your thinking skills. Okay, thank you so much.